comparing the volumes of shapes that have the same base, same height. So in this lesson, what I want to do is basically show you the relationship that exists between prisms and pyramids, or in this case, a cone and a cylinder. In other words, two shapes that have the same base and the same height. So let's consider this, a cone and a cylinder that have the same base, so the same dimensions for the base. So let's assume that this is equal to r as the radius, and this is the same thing. So that means they have the same diameter, and also they have the same height. So how, let's write down height here. So how do these two shapes, in fact, let me draw it on the other side. No, it's fine. It's fine. Change my mind. How do these two shapes, the volume of each of these two shapes compare with each other? You may have learned this before. You may have heard about it. Okay. In case you're not sure, how do these two volumes compare? In essence, it's like this: the volume of the cylinder, yes, the volume of the cylinder, the shape right here, is it's equivalent to the volume of the cone multiplied by 3. Once again, the volume of the cylinder is equal to the volume of the cone multiplied by 3. And I'll actually repeat it one more time with more detail. So, meaning, if you have a cone and a cylinder that have the same height and the same diameter, then the volume of the cylinder is equal to the volume of the cone that has the same height and same diameter multiplied by 3. Okay, so now let's actually formalize this in a more mathematical way. So we can say that the volume of the cylinder, and as always, you can pause the video to take notes. So the volume of the cylinder is equal to the volume of the cone times 3. This is very useful because we're going to see in the future lessons some examples related to this. And hence also we could also say that the volume of the cone, it's equal to, what would you say? If we had the dimensions, if we had the volume of the cylinder, how would you get the volume of the corresponding cone that has the same height and same diameter for its base? Well, we can say that the volume of the cone is equal to the volume of the cylinder, of its corresponding cylinder with the same height and same diameter, divided by 3. So volume of the cylinder divided by 3. And if you take a look at their formulas, you can see that this is true as well algebraically. So here it is. Here's the formula of the cylinder. Volume equals pi r squared times height. Well, and guess what? What is the volume of a cone with a corresponding, that has the same height and same radius or same diameter as the cylinder? Well, for the cylinder's V equals pi r squared times height. Well, the volume of a cone is pi r squared times height divided by 3. So you can have your formula sheet handy, and you can see that this is true for all of them. Now let's compare other shapes. Right here, let's compare other shapes, and the same applies to this, to a rectangular base prism, right, that has the same height. So actually I didn't draw the height, you can draw it right now, right? right? That's the height. This is the height as well, right? And it has the same dimensions for the rectangular shape. Well, how do the volumes compare? Well, the volume of this pyramid that has the same height and same shape, you multiply this times 3 in order to get the volume of this rectangular prism. So, just like the previous example, we can say that the volume of the rectangular prism, so I'm going to say R prism, because I don't want to write this long. So R dot prism, so the volume of the rectangular prism is equal to the volume of its corresponding rectangular pyramid times 3. And the volume of a rectangular pyramid, as you may have guessed it, it's equal to the volume of the rectangular prism divided by 3. Let's move this up a little more. Divided by 3. Right? And this applies to all types of prisms. So it doesn't matter the shape, as long as the height and they have the same shape, same dimensions for the shape. So let's assume that this is A and this is B and this is A and this is B. So same thing. Right? Let's check out one more. Right? And this is a triangular prism. So same thing, that has the same height. Right? Both of these have the same height. Sorry, it's not that clear to get the height here, but same thing, right? And they have the same dimensions for the triangular base, right? So let's call this A, let's call this B, let's call that C. So A, B, C. So same thing. The volume of this triangular prism, it's equivalent to the volume of its corresponding pyramid multiplied by 3, meaning corresponding that has the same height and the same base. So we can say that the volume of the triangular T prism, okay, so triangular prism is equal to the volume of the triangular pyramid times 3, and the volume of the triangular pyramid, it's equal to the volume of the triangular prism divided by 3. And if you compare the formulas, they all support this relationship.